Hey guys, so today we are looking at Algebra 3's 5.1 Day 2 notes. Let's go ahead and get into it. Now, this lesson is all about getting comfortable with radians and then a couple of other side things about definitions of angles. So, the first thing we're going to do is look over the initial side, terminal side, coterminal angles, central angles. We'll mess around with these for a little bit, and then we'll talk about finding coterminal angles given other angles that are coterminal. And then the big thing is memorizing common radian measures. And then we're going to find a length of a circular arc given by a central angle and radius. This is basically just a side thing that's not very difficult or anything. The majority of the lesson comes here. So, first off, the definitions. We start off with the initial side. And the initial side is the starting side of an angle. So when you make an angle, it's got there's an angle. Well, this would have been that's the worst brace. This is really bad. That's still pretty bad, but anyway. This would be the initial side, and then since I ended over here and the rotation went this way, this would be the terminal side. So that's like a quick explanation. So we've got these two definitions side by side, initial side, terminal side. And the big thing is the angular rotation, right? Because when we're dealing with some of these more complicated angle measures, you'll need to know what the angular rotation is. And later on in future math classes, you might start mathematically working out angular rotation, maybe in physics classes as well. So here's your standard position of an angle. This would be your initial side. And so let's draw a couple of angles. So one angle could look like this. So this is the initial side, and then it rotates around this way. And there's your terminal side. So this would be the terminal side. This indicates the rotation, this arrow here, and this is the initial side. All right, that's just one quick example. So maybe you've got something that looks like this. So your angle goes this way, and then maybe it goes this way, and it rotated that way. There's another initial side, terminal side. And then maybe it goes like this. So there's the rotation. Here's the terminal side. Here's the initial side. All right, hopefully that gave you the idea. Now, coterminal angles. Angles are coterminal if they have the same initial and terminal sides. So consider the following angles. Pi over 2, we went over this on day 1. Pi over 2 is a 90-degree angle, and a positive pi over 2 rotates counterclockwise like this. So this is your pi over 2 angle. Well, 5 pi over 2 is 4 pi over 2 plus 1 pi over 2. And 4 pi over 2 is 2 pi. So that is 2 pi plus pi over 2. And if you remember from the last lesson, 2 pi is a full rotation. So it would be a full rotation followed by another pi over 2. And it would look exactly the same. Well, if I can draw correctly, it would look exactly the same. These two angles, here's your initial side, here's your initial side, here's your terminal side, here's your terminal side. The position of the initial side and the terminal side is identical. The only difference is the number of rotations you created to get to that point. These are called coterminal angles. So we're going to go through some examples. Notice how they have the same initial side and terminal side. Coterminal angles can always be found by adding or subtracting 2 pi radians or 360 degrees to your existing angle. And that should make sense because this is the example of if you took an angle and you added 2 pi to it, you would get 5 pi over 2. And it's the same exact angle in appearance, but not in actuality. On the other hand, if you took pi over 2 and subtracted 2 pi from it, you'd be going negative So you got 2 pi minus pi over 2. Or excuse me, that's wrong. You're taking pi over 2 minus 2 pi. There we go. So that's really pi over 2 minus 4 pi over 2, if you want to get into common denominators. And then that's negative 3 pi over 2. Should be a coterminal angle. And let's see if it is. So remember, every pi over 2 is like a 90 degree. And if you go negative, that means you're rotating this way. So 1 pi over 2 would be here at 90. 2 pi over 2 would be here at negative 180. And then 3 pi over 2 would go right to there. And you'd have an angle that looks just like this. Another coterminal angle. Okay, so the idea is every 2 pi that you add or subtract to an angle, you'll get coterminal angles. Or, alternatively, if you are in degrees, every 360 degree. So, let's go ahead and look at some examples. Find a positive angle less than 360 degrees. So this is your restriction. A positive angle less than 360 degrees that is coterminal with each of the following. Now, so these are separate examples, by the way. So 420 degrees. First off, we're in degrees, so we're going to be looking for like these conversions using degrees. So a full rotation in degrees is 360. So you'd want to add or subtract to get your coterminal angle. And in this case, we want to subtract 360 degrees. And the reason you subtract 360 instead of add is because we placed an initial restriction on us that our coterminal angle needs to be less than 360 degrees. If you added 360 to 420, you would find a coterminal angle, but that would be an angle that is more than 360 degrees. And that's not what we want. So we're going to subtract 360 degrees instead, and you will get 60 degrees. So our coterminal angle to 420 degrees is 60 degrees. So if you were to draw these angles, you'd get like 60 degrees, and then 420 would be 360 degrees, full rotation, plus another 60 degrees. And that would be the 420 degree. Next, we've got negative 120 degrees. So again, we should know that you need to add to this negative 120 because we are supposed to find a positive angle. And so to get a negative to become positive, you're going to need to add to it. So add 360 degrees, and you're going to get 240 degrees. So 240 degrees would be your coterminal angle. Moving on, 17 pi over 6. First off, these are in radians, so you're no longer going to be adding and subtracting 360 to this. Second, we need to establish, is this already greater than 2 pi, or is this less than 2 pi? These are important questions because here we knew to subtract 360 because we wanted a positive angle less than 360, and 420 is more than 360. So this is a lot easier for us to know that, oh, you subtract because we're trying to find an angle that's less than 360 degrees. But remember, in radians, this is 2 pi. So we're trying to find an angle that is less than 2 pi, but is also positive. That is coterminal. So we need to figure out, is this already greater than 2 pi? And the answer is yes, because I'm going to look at the denominator, okay, the denominator, and that is 6. And so what numerator would have to go with pi? Well, that's a terrible color. What numerator would have to go with pi to reduce down to 2 pi if the denominator was 6? And the answer is 12, because 12 over 6 is 2. So with the same denominator, if we had 12 pi over 6, that would be 2 pi. This is more than that. This is 17 pi over 6. So what we need to do is we need to subtract 2 pi, a full rotation, to get a coterminal angle, just like we did here. You subtract full rotations or add full rotations to get coterminal angles. So In our case, we're going to take 17 pi over 6 and subtract 12 pi over 6, which is 2 pi. And you will get 5 pi over 6. And that's that. Now here, this is negative, so I already know right off the bat you're going to have to add 2 pi. So let's do that. So we're going to add 2 pi, and we want to find a common denominator if we're going to do it by hand. So to find the right numerator to match this denominator, you just double it since you're looking forward twice. So you're going to get negative pi over 12 plus 24 pi over 12. 24 over 12 reduces to 2 over 1, which is why we do this. 2 pi is a full rotation. And that equals 23 pi. So our answers here are 5 pi over 6 and 23 pi over 12, because I'm stupid. This is actually over 12. I was going to say something's wrong here. Well, there wouldn't be a lesson if I didn't get tripped up somewhere. Now, if you have any questions with that, please ask me them, okay? Now, moving on. Memorizing common radian measures. This is the most important slide in this lesson. And man, that is true. Your ability to know this is just going to be super, super, duper, duper important. All right. So, on the first day's lesson, we did a bunch of conversions, right? We converted pi over 6 and pi over 2 and 3 pi over 2. We went through all the common ones like pi over 2, pi, 3 pi over 2, 2 pi, pi over 6, pi over 4, pi over 3. Well, here, we are going to do every increment of 30 degrees and then every increment of 45 degrees. So this is a 30-degree angle. Let's do it in red, shall we? This is a 30-degree angle. So here's your 30 degrees. Here is another 30 degrees. And here's another 30 degrees. So this is 30 degrees, 60 degrees. I know it doesn't look quite right, but it is. This is the way the indicator's going to go. It should be like a little farther down, probably like around there. But, oh well. And then this is another 30 degrees. This is another 30 degrees. This is another 30 degrees. And then all these red hash marks are more 30 degrees. Another 30, another 30, another 30, another 30, another 30, and finally a full rotation. Now, here's the idea. We can go ahead and label these in degrees. Super easy. 30, 60, 90, 120, 150, 180, 210, so on and so forth, right? But we are going to use radians here. And using radians gets a little more tricky. So, man, this never quite erases it. Get out of here. It's like it's hiding there and I just can't see it. Okay, so radian measures. First off, I'll go ahead and tell you that a 30-degree angle in radians is pi over 6. So if pi over 6, let's cross this out. If pi over 6 is 30 degrees, if you're going to add another 30 degrees, getting us here to the next red hash mark, that's going to be another pi over 6. So this is the way I like to teach this. Every one of these angles is another pi over 6. So if this was 30 degrees and this is 60 degrees, if you take 30 and add 30 more to it, you will get 60 degrees. So if you take a pi over 6 and add another pi over 6, you will get this angle. So you take 1 pi over 6, this next one is a second pi over 6. So now we have the 2 pi over 6. So 2 pi over 6 can reduce into 1 pi over 3. So this angle here is pi over 3. So here's our, where's our pi over 3? There it is. So here's our pi over 3. Cross that out. So we've got pi over 6, then pi over 3, because that's 2 pi over 6. And then this next hash mark here becomes 3 pi over 6. And we can just go ahead and continue this. This is 4 pi over 6. This is 5 pi over 6. This is 6 pi over 6. This is 7 pi over 6. You're going to add another pi over 6. So you're going to get 8 pi over 6. Adding another one, you're going to get 9 pi over 6. And then you're going to get 10 pi over 6. 11 pi over 6. And then 12 pi over 6. So every time you add 30 more degrees, you add another pi over 6. And the only difference is now some of these can reduce. So this 2 pi over 6 reduced to 1 pi over 3. 3 pi over 6 can reduce into pi over 2. 4 pi over 6 can reduce into 2 pi over 3. 5 pi over 6 cannot reduce any further. 6 pi over 6 is just pi. 7 pi over 6 can't reduce. 8 pi over 6 can reduce into 4 pi over 3. 9 pi over 6 can reduce into 3 pi over 2. 10 pi over 6 can reduce into 5 pi over 3. 11 pi over 6 cannot reduce. And 12 pi over 6 can reduce into everyone's favorite 2 pi. Wow, no. No! No! Wait, just a second. Hang on. Sorry about that. That was my dad calling me. So, those are all of our 30-degree angles, our pi over 6s. So let's go ahead and cross these off. So we got pi over 2 out of the way. And then we got 2 pi over 3 out of the way. 2 pi over 3. And then we got our 5 pi over 6. So that's here. Then we got our pi, which is not on here. And then we got our 7 pi over 6, which is right here. And then we got our 4 pi over 3, which is here, and our 3 pi over 2, which is here, and our 5 pi over 3, and our 11 pi over 6. All right. Now, that is all of the pi over 6 30-degree angles. The next one is these blue hash marks, and the blue hash marks are pi over 4s. So these are every quarter pi. So there's a pi over 4, there is a pi over 4, there is a pi over 4, there's a pi over 4. And this first grouping should make sense. So let me go ahead and erase these red hash marks so we can see a little better. So we'll try to wrap this up in the next 5 or so minutes, just so you know. Now, we've got each of these angles is a 45-degree increase. So 45 degrees, another 45 makes 90 degrees. That should make sense, 90 degrees. And then another 45, and then another 45, and that makes your 180. But every 45 degrees is a single pi over 4. Because 180 degrees, right, this is 1 pi. And if you cut it into fourths, you're going to get each of these slices here. And so a fourth of a pi is pi over 4. So then a second slice would be 2 pi over 4. A third slice would be 3 pi over 4. And then your final slice would be 4 pi over 4, which is just pi. So that's how these ones go. And 2 pi over 4 reduces in 2 pi over 2. These cannot reduce. Then here, this is another slice on top of your 4. So you had 4 over 4. Now you've got another slice. That's 5 pi over 4. Another slice is 6 pi over 4. We've already got that labeled though. 3 pi over 2. And then another slice is 7 pi over 4. And then your final piece, this would be 8 pi over 4, which we've already labeled to 2 pi. So that's how these work. Now, if I was to draw this for you, here's how I would do it, right? There's a trick to this. Well, ish. Well, I won't even teach you. I'll wait for the unit of the circle. First off, what I would have memorized in your head right now anyway, is that 30 degrees, every 30 degrees is another pi over 6. I would even write that down. Every 30 degrees is another pi over 6. And then I'd say every 45 degrees is another pi over 4. So if I was thinking, well, I've got 60 degrees. What is that? Well, that's 2 30 degrees, and every 30 degrees is a pi over 6. So you got pi over 6, 2 pi over 6. All right, that's right now, that's the best thing to get started with, all right? Moving on, the last thing we're covering, the length of a circular arc. This doesn't have much to do with what we've been talking about, but we're going to go ahead and get into it. It's just a quick little formula. If S is the circular arc length, and R is the radius of a circle, and theta is the central angle in radians, and a central angle is an angle whose vertex is at the center of a circle, like we've been doing this whole time. All of these angles we're forming are central angles because the vertex of the angle is in the center of a big circle. Then the arc length is equal to the radius of the circle times the angle in radians of the central angle, like the measure of the angle in radians of the central angle. So the arc length, this right here is what I'm talking about for arc length. That length there. So if you were to take this, if you were to take like a I don't know, like a string and go closely along the edge here and then stretch it out to be straight, that would be the length that we're looking for here. And the length of this arc length is the radius times the central angle. And the central angle is 120 degrees. So this is 120 degrees. But, and our radius is 10. So S is supposed to equal, the arc length is supposed to equal the radius times theta in radians. Right now it is in degrees. So you have to think, what is 120 degrees in radians? Well, we just did this up above. But you can also think of it as this, right? If every 30 degrees, just off of this, if every 30 degrees is pi over 6, 120 is 4 30 degrees. So this should be 4 pi's over 6. You follow along there? If every 30 degrees is 1 pi over 6. To get from 30 to 120, you multiply by 4. To get from pi over 6 to 4 pi over 6, you multiply by 4, right? That's what the conversion I just did in my head, right? Eventually, you should memorize that this is just 2 pi over 3. But until then, this will have to do. So this is going to be 10 times 2 pi over 3. And that will give you approximately, if you want to keep it in exact terms, this is going to be 20 pi over 3. And then if you want to approximate, this is around like 20.94. All right, now you guys try this one. The radius of a circle is 7 feet. Find the length of the arc intercepted by a central angle of 135 degrees. This is like sort of the lingo you'll expect to see. The radius of a circle, 7 feet. Find the length of the arc intercepted by a central angle of 135 degrees. So if you think you can do that, go for it. All right, so arc length is equal to radius times the central angle. Well, that is 7. And then we don't know the central angle in radians, so we're going to have to convert 135 degrees to radians, which we can convert like this. and that gives us 135 pi over 180, and that reduces into 3 pi over 4. That's if you want to just do the raw conversion right away without using the measures above. So this would be 7 times 3 pi over 4, which would be 21 pi over 4. And that is approximately 16.493 feet. That's a 9, by the way. I know it doesn't look like a 9, but... All right. Now, for your homework. Here's your homework. So there's only like a handful of problems. But then what I want you to do is I want you to draw and write out 3 identical circles, all with the radian measures shown on slide 5. And this is slide 5, this one right here. So I want you to draw out this circle, and I want you to try to by the 3rd circle, I want you to not use your notes. Like, that's the whole goal here, right? So make sure you can memorize these. And on the circles, what I want are the radian measures of the angles going all the way around the circle. So that is at 30 degrees, at 45 degrees, and at 60 degrees, and then 90 degrees. And then every further 30 degrees, and then every further 45 degrees from here, right? So, pi over 6, 2 pi over 6, which is pi over 3, then 3 pi over 6, which is pi over 2, then another, right? Do that all the way around. Do not do each circle at the same time. Like, not each circle. Do not do all circles at the same time. Do them one after the other, right? There's your homework. Get to it. Let me know if you have any questions.